Welcome to VEENAASRI Tuition and Coachings. Current Electricity 8 marks, second year IPE. Long question. State Kirchhoff's law for an electrical network. Using these laws, deduce the condition for balance in a Wheatstone bridge. Kirchhoff's laws, right? Kirchhoff's laws. By using these laws means Kirchhoff's laws, you write a condition for Wheatstone bridge. Kirchhoff's laws మనం రాసి డిఫైన్ చేసి వీట్స్టోన్ బ్రిడ్జ్కు కండిషన్ అనేటువంటిది వీట్స్టోన్ బ్రిడ్జ్ యొక్క కండిషన్ను మనం డిరైవ్ చేయాలి. నా సో ఫస్ట్ రైట్ కిర్చాఫ్స్ ఫస్ట్ లా అండ్ సెకండ్ లా. కిర్చాఫ్స్ first law, or another name is current law, junction law. At any junction in an electric circuit, the sum of entering the junction is equal to the sum of currents leaving the junction. At any junction in an electric circuit, the sum of entering the junction is equal to the sum of leaving the junction. Symbolically, sigma I is equal to 0. This law is based on the conservation of charge. So, suppose you take a current I1 current, so it is a junction. Next, I2 current entering into the junction, I3 current also entering into the junction. Next, I4 current leaving from the junction, I5 current leaving, I6 also leaving from the junction. So symbolically we write I1 plus I2 plus I3 is equals to I4 plus I5 plus I6. See, sum of currents entering into the junction, that is I1 plus I2 plus I3 is equals to leaving the junction I4 plus I5 plus I6. So once again listen, I1, I2, I3 entering into the junction, I4, I5, I6 leaving currents from the junction. So entering is equals to leaving the currents. This law is based on the conservation of charge. ఈ లా అనేటువంటిది కన్జర్వేషన్ ఆఫ్ ఛార్జ్ మీద డిపెండ్ అయి ఉన్నదన్నమాట. ఓకే, నెక్స్ట్ ఇట్ ఈస్ ఫస్ట్ లా. నెక్స్ట్ సెకండ్ లా, కిర్చాఫ్స్ సెకండ్ లా, వోల్టేజ్ లా. అనదర్ నేమ్ ఈస్ లూప్ లా. The algebraic sum of changes in potential around any closed loop involving resistors and cells in the loop is 0. The algebraic sum of changes in potential around any closed loop involving resistors and cells in the loop is 0. That is sigma V is equal to 0. This law is based on the conservation of energy. So we will discuss clearly in another questions. Here ఇక్కడ మనకు అడిగింది ఓన్లీ డెఫినేషన్స్. ఓకేనా? Wheatstone bridge. See here, I1, I3. So you take A, B, C, D. So here R1 resistance, R2, R3, R4 resistors. These are the current flowing through A to B is I1, this resistor, B to C is I3, A to D is I2, D to C is a current flowing I4 current. So it is a battery. The circuit shows in the figure is called Wheatstone bridge. It is a circuit diagram. The circuit shows in the figure is called Wheatstone bridge. It has 4 resistors. It has 4 resistors R1, R2, R3 and R4. Full stop. AC is the battery arm. AC is the AC is the battery arm. Here from A to C, what is there? Here battery is there. We are saying battery arm. Next, BD is the here B to D. What is there here? Galvanometer. BD is the galvanometer arm. BD is the galvanometer arm. The galvanometer G deflects. The galvanometer G deflects the current. Deflects the current. So when the current is flowing, the galvanometer G is in this point. Needle is deflecting, means moving. ఎప్పుడైతే galvanometer current పాస్ అవుతుందో నీడిల్ అనేది మూవ్ అవుతుంది. If the resistors are adjusted, the resistors are adjusted such that the galvanometer current Ig is equals to 0. The bridge is said to be balanced. Applying Kirchhoff's junction rule. Applying Kirchhoff's junction rule at B, we get I1 is equal to I3. See the diagram. Applying Kirchhoff's junction rule at B means entering the current is equals to leaving the current. That is I1 is equal to I3. Similarly, applying Kirchhoff's law at D, junction D, I2 is equals to I4. So you take it as first equation, you take it as second equation. I1 is equal to I3, I2 is equal to I4. I1 is equal to I3 at junction B is take it as first equation. Next, similarly, applying Kirchhoff's junction rule into D, we get I2 is equals to I4. I2 is equals to I4. Take it as Second equation, applying Kirchhoff's rule to closed loop. Applying Kirchhoff's loop. Kirchhoff's loop rule to closed loop. Closed loop, we get I1 R1 I1 R1 I1 R1 plus 0 minus I2 R2 is equals to 0. Since Ig is equals to 0, the galvanometer current Ig is equals to 0. I1 R1 plus 0 minus I2 R2 is equals to 0. See here, closed loop A, B, C, D. I1 R1 galvanometer 0, I2 minus I2 R2. So this direction we are taking A, B, C, D loop, same direction I1 R1 positive to 0. So D to A this direction, but current flowing this direction, both are opposite, so you take it as minus I2 R2. It implies I1 R1 is equals to I2 R2. It is also is equals to I1 by I2 is equals to R2 by R1. Take it as third equation. Similarly, closed loop B, C, D, B. We get I3 R3 is equals to I4 R4. It implies I3 by I4 is equals to R4 by R3. Substitute one and equations or from one and two equations. It implies I1 by I2 is equals to R4 by R3 from 1 and 2 equations. So instead of I3 you substitute I1, instead of I4 you substitute I2. So that I4 is equals to I2, I3 is equals to I1. We get I1 by I2 is equals to R4 by R3. You take it as fourth equation. Next, from third and fourth equations. From third and fourth means third equation is I1 by I2 is equal to R2 by R1. Fourth equation is I1 by I2 is equal to R4 by R3. Here I1 by I2, I1 by I2. So you will get R2 by R1 is equal to R4 by R3. R2 by R1 is equals to R4 by R3. This is the balance condition of Wheatstone bridge to make Ig is equals to 0. This is the balance condition. Therefore, this is the balance condition. This is the balance condition of Wheatstone bridge. Wheatstone bridge to make Ig is equal to 0. Ig is equals to 0. సో ఐజీని జీరో చేయడానికి గాల్వనోమీటర్ కరెంట్ జీరో చేయడానికి బ్యాలెన్స్ కండిషన్ ఆఫ్ వీట్స్టోన్ బ్రిడ్జ్ ఇట్ ఈస్ R2/R1 is equal to R4/R3. So you write it also implies, so you write reverse R1/R2 is equals to R3/R4. You write like this also. Thank you.